So sorry, we got cut off a little bit there, but here's part two. Here, so we were kind of looking at the animal kingdom, right? And we notice and recognize a lot of things down here, but all these other things, even at the top, all of these things are alive, including things like bacteria, which are germs, a little bit different than viruses. Viruses and bacteria are different, but bacteria are actually alive. So now we're going to go to this main understanding and hopefully having a broader idea of what means to be alive. We're going to go to the next slide and remind ourselves that living things have cells, because that's the unit that we're going to be talking about really for the rest of the year. But when you take a look at it, how tiny are living things? Well, if you go down to the next slide and we go down to cells, there's this link here, and I want you to check it out kind of on your own, but I'll show it to you a little bit. You're going to click on it, and it's going to take you to this size and scale website. It's kind of cool because it starts off by saying, okay, here's 12-point font. Here's like what a coffee bean size would be. And then what you're going to do is you're going to take this scroll at the bottom and you're going to move through, and it's going to take you through all the way to the size of a cell. So let's start again. Here's like a grain of rice, right? Here's a coffee bean. So think about how small those things are. Now we're going to get smaller and we're going to see all the things on the way to an actual cell. So keep going, keep going. There's a skin cell and a red blood cell. We're getting there. Some of these things you might have heard of or seen pictures of, and some of them you might not have. Well, let's keep going. So look at this. Wow. Oh my gosh. So we've got the virus here. We've got influenza. We have another virus here. Influenza is like the flu. So let's keep going. Oh my gosh. Oh my gosh. Oh my gosh. Here we go. Here we go. Here we go. All these other things. Here's a water molecule. Here's a carbon atom. Okay, so kind of getting you an idea of how small and tiny things are. Atoms are really small. We talked about them earlier at the beginning of the year. But if you take a look at these other things, this is how small cells are. So going back, and bacteria, cells are really, really, really tiny. Okay, so that kind of gives you an idea. And then we go all the way back. Look at, you can't even see the cells anymore, really. And then we go all the way back and look at how big the coffee bean looks. So it's kind of a cool thing to check out if you want to on your own, but you get an idea of how tiny cells are. Very, very, very tiny. We would never be able to see one just on our own. We need a really powerful microscope. Okay, so the next part that we're going to talk about really quickly is the difference between some living things that have one cell and some living things that have multiple cells. And it's pretty simple. We have organisms like the two at the top of this chart here that have only one cell. And if you can kind of take a look at it, there doesn't seem like there's, at least up here, there doesn't seem like there's much going on in terms of complexity, right? So they're simpler. We call them unicellular organisms, and uni means one. So they have one cell. So even if you have one cell, you are still considered alive. But then there are a little bit more complex things like this horse here and the tree, and we can see the yeast and the mushrooms that are made of many cells. In fact, our body has trillions of cells, so many cells. So we would be called multicellular organisms, multi meaning many. All right. Lastly, we're going to talk about how the fact that there's different kinds of cells. So even though living things are made of cells, especially when you think about humans, we have a lot of different kinds of cells and they all look different. Take a look at all these pictures. These are all different kinds of cells. Kind of funky, right? And what's kind of interesting is that every cell and their shape often looks like what they have to do. So we say that cell shape often matches with their function or their job. So if you take a look at it, here's what muscle cells in the body look like. And if you can kind of see, they look like they could kind of be almost like an accordion where they go in and out and in and out, right? That's because your muscles, think about it, if you take your arm and you pull it in or out, you're contracting, right? And constricting your muscles. So they have to be able to move. Nerve cells take important things in your body and like messages and transmit them throughout the whole entire body. So they need to have arms.